In the first section of 5.2, we're going to look at graphing polynomials. Now, even though yesterday we were sketching out quartic polynomials and even stuff that went up to like the 11th power, we're only going to be looking in this unit at functions no greater than cubic, so no greater than the power of 3. So if you were given an equation like this, y equals x plus 2 times x minus 1 times x minus 3, I want to graph the function. That's going to be our goal for tomorrow. So something really helpful here is going to be to find the zeros first. So using the zero product property, I can easily look at this equation and think about, okay, what could x be to make this whole equation be 0, aka my values of my zeros. So looking at this, in that first parentheses, x could be negative 2. For the second one to work, x could be 1, and x could be 3. So right out the gate, I already have 3 coordinates to be able to graph this polynomial function. So from here, I'm going to want to try to figure out what are those values in between so I could get a better idea of what this graph looks like. So here in the notes, I'll show you how to do this by hand. You don't need to write this down at all, but just to show you kind of where these numbers come from. If I'm inputting negative 1, I could plug that into the equation. I could plug that in for x, and I would get 8. So my coordinate's negative 1, 8. For 0, I would get 6. And for 2, I would get negative 4. Now, when we do this in class, we're going to figure all these out in the calculator and by kind of tracing along our graph. You don't need to do these by hand. Again, this is just to kind of show you where those numbers come from algebraically. You don't need to write that down. So the next thing that you're going to need to know is a relative max and min. So after I've kind of plotted some coordinates, the next thing I want to know is what's my relative highest point and what's my relative lowest point. Before, when we talked about these, we were looking at quadratic functions where it would only have like a bottom point or like a minimum or a high point and a max. As we can see in cubic functions, since we turn multiple times, we can have both a max and a minimum value. A relative maximum is what you would see in red there, the value of a function at an up-down turning point. And similarly, a relative minimum is the value of a function at a down-up turning point. When we find these tomorrow, all of them are going to kind of be weird decimals. We're going to learn how to find these in the calculator. So when I'm graphing my function, in the top left, I can see all the coordinates that I've either traced on the calculator or just kind of found that are nice whole numbers. Next, I want to find my relative max and min. So when I do this in the calculator, I'm going to see that my relative max is negative 0.786821. And my relative minimum value is 2.12, comma, negative 4.06. Also, since I'm looking at a graph of this, I can see that my graph looks something like this. Therefore, the end behavior, by looking at it visually, is down and up. So my very last step to kind of put this all together to graph it is I want to plot all my points and connect the dots. So I'm going to plot negative 2, 0, negative 1, 8, my relative maximum value, 0, 6, 1, 0, 2, negative 4, my relative minimum value, and 3, 0. And from here, since I know that this function is going down and up, I'm going to connect the dots going in that kind of direction. So I'm going to start moving down, and then I'm going to go up, and I'm going to end my graph moving upward, and I'd be done.